In this example, we're going to do use the direct comparison test again for a series example. However, this one's going to be a little bit more complicated and involves some playing around with some factorials that I figure would be useful to see an example of. Alright, so this series that we're interested in is the series from n equals 1 to infinity of n factorial over n to the n. And we're being asked to determine whether or not this converges or diverges. Now, as you do more and more series problems, you should get more and more comfortable with looking at them and getting a sense of whether or not you think they converge or diverge. In particular, you need to make sure that the terms go to 0 fast enough in order to make the whole series converge. Well, we know that factorial grows really fast, but n to the n grows even faster. Okay? So these terms are going to 0, and this one gets to 0, gets really, really big, really, really fast, even in comparison with the factorial. So we have an inkling that this series might converge. All right, so to show that in this case, we're going to compare this series to the series n equals 1 to infinity of 2 over n squared. Okay? All right, to see where the 2 over n squared comes from, we'll just start playing around with the terms and see what happens. Certainly these terms only have positive terms in them. Remember, that's a requirement of being able to use the direct comparison test or the limit comparison test, is that we have all positive terms for our series. All right, so let's look at the terms of the original series that we're interested in, the n factorial over n to the n. Well, remembering n factorial is n times n minus 1 times n minus 2 all the way down to 1, we notice if we just were to write out the top and the bottom, say in longhand, both of them are going to have n factors in them. The top will be 1 times 2 times 3 all the way up to n. The denominator will be n times n times n, n times. All right. For the time being, ignore the first two terms in this product. Let's look at the last terms. We have 3 over n, then we would have 4 over n, and then we would have 5 over n, all the way up to n over n. Well, certainly all of these terms will all be less than or equal to 1. So if we replace all of them with 1, we get a bigger product. Or at least a product that's at least as big, but probably bigger. So if all of those terms, if we replace them with 1s, that product's going to turn out to be 1. And all we're left with is 1 over n times 2 over n, which is the same thing as 2 over n squared. I do need to make sure that this is for n greater than or equal to 2, because if n's equal to 1, we really only have the 1 over n term, right? We don't get the second term there. All right, so now if we look at this series that we're comparing to, this is a constant multiple, 2, times a p-series. The p-series here has a p equal to 2 as well. That series converges, so 2 times it will also converge, which is good news for us because that's the bigger series. So if the bigger series converges, the smaller series also converges by the direct comparison test.